Thanks, Shirley. So our project is about conversational AI. Specifically, we have named it as Neural Agent Assistant for Customer Service Support. So this is from Shirley, Elaine, and Elham. So to start off, we will want to give you a quick introduction about what is Neural Agent Assistant for the customer service support. Then we're going to talk about question intent identification, which is broken down into two sections: predefined classes on top of few shot learning, as well as pre-trained prompt and predict. As then we're going to talk about question answering and give you a demo on the different models that we have trained, as well as an end-to-end pipeline. So to start off, what exactly is Neural Agent Assistant for customer support? So the idea is that we want to have a better understanding on the customer's questions during a conversation. At the same time, we, as an agent, we want to provide some relevant information from a knowledge base and still be able to generate some natural, sensible, and specific responses to the customer. So this is broken down into 3 tasks. So to start off with, upon receiving a customer's question, we're going to have a question classification model in which that we see whether this is just type of how are you questions or it is a request. So if it's a how are you type of questions, a dialogue GPT is going to be activated, and then it's just going to talk to the customer. But if it is a request, then our neural agent assistant is going to be activated, in which that we're going to have an intent identification on the question that the customer asks, as well as that we have a pre-trained sentence transformer that is able to give us some context retrieval. And this context is acted as a knowledge to the response generation, in which that we're going to generate a response to the customer. So intent identification is broken down into the 2 big categories. One on the left side, we see that is the predefined classes. So pretty much that is just that we, upon receiving the question from the customer, we're just having a softmax activation in which that we know which this question belongs to in the predefined classes. So on the right side is the mass language modeling fine-tuning, in which that upon receiving the question, we're going to add on top of it saying, oh, the problem is related to slot. The slot is our intent. So our model is going to output us the intent as well. So after some experimentation, we see that the predefined classes have a lot very good performance. So we decided to do a few more experiments in which that we did few shot learning. So the idea of it is that we pre-trained dataset A, in which we get the classification factors. So this is acted as a feature extractor, and that is going to be trained on dataset B, in which we're doing a similar thing, still like softmax, but this time with new classes. And we'll be showing you the demo on these 3 models later.
Yeah, I'm also going to talk about like the part 2, which is like the response generation part of the Neural Agent Assistant. So specifically, we wanted to initially build like a chatbot that could do it all, but it turns out that is very hard to do. So we decided to focus in for this part on specifically being able to answer questions from the customer, since that is an important part of being able to help a customer, is being able to give accurate responses to what they ask. So specifically, the way that the chatbot works is it takes in a context, which should include the answer as well as the question from the user, and it will try to extract the answer from that context. And as well as on top of that, it is trying to answer the question in a sort of like natural dialogue, full sentence format, instead of just sort of extracting just the part of the answer. The context retrieval part is done by the sentence transformer, where we assume that the user will have some sort of like large list of paragraphs and like context in which like the sentence transformer will pick a good one and give it to the model. So far the model has been shown to perform very well on like context that it's never seen before, but a good answer depends very much on like whether or not the answer is actually present within the context of the context itself. So for now, I will turn it over to Elaine to show off the intent identification models.
Thanks, Shirley. Just let me screen share. Okay, so this is the predefined classes interactive mode. So upon, for example, the agent is going to ask, how may I help you? And then the question I could write, I lost my password. So right away, this model is able to identify it's related to passcode forgotten. So this model is trained on a banking data set. So everything on the classes are related to the banking. So let's try another one. I bought an item and noticed the exchange rate was not correct. So this one right away is able to see that, oh, it's related to card payment wrong exchange rate. And then it has a 98.99 confidence percentage. And if I say delete these accounts, it's related to terminating accounts. So that is the idea of the predefined classes. So there is 77 classes that are defined. But if we want to look a little closer, explainability in terms of models are one big question in using BERTs or neural networks. So with this, we are able to, I want to show you another, when we're predicting, we are able to see like a visualization on which token or which word is actually having more importance in terms of the classifying. So same question this time, but right away, we're able to see that like a visualization that the word password is much more important. That's why is predicting the password forgotten. And if we do another one, can you assist me with the auto top up? So right away is able to see that it's related to automatic top up. In here, I guess the auto is playing an important word. That's why it's predicting this. So that is the idea of the predefined classification model. So if we look at the few-shot learning one, so the few-shot was using the previous model that we just showed, but we were training on another data set that is related to banking, but this time instead of 77 classes, we only have 15 classes. So these are the classes that are we have. So this time, let's give it other questions, such as, my card is lost. What can I do? So this time we're able to see that it shows report lost card because that is one of the intents. But we notice that the confidence is much smaller because it's just not very confident in terms of predicting because of the few-shot learning. So let's give it a try on the other stuff. What do I do when my card expires? So we know that it's expiration dates, which is self-explanatory. Are there any fees for adding money with an international card? So right away, we know it's international fees. So that is pretty much the idea of the few-shot learning. And if we move to our mass language modeling that we just talked about, this one is very unstable, but I believe that there is a lot of potential with this. But let's just give it an example. I want to do a cash top up. So great, like right away, we know it's related to topping cash. But I think if we say how long until my card is delivered, so it knows that is related to Visa card, but maybe that is not exactly the intent that we're looking for. Maybe it's like a delivery time, that would be the intent. Same question, I lost my password. So right away, we just see that it's related to loss, but not exactly lost password or passcode. So that is the three modules that we have done for intent identification. And now I'm going to stop sharing and pass it on to Shirley.
Thanks, Elaine. All right, so now I'm going to talk about the question answering model part of the neural agent assistant. So more specifically, this model is using the GPT-2 backbone. The one that I'm going to be showing off is using GPT-2 medium, but our code is able to easily use any sort of like GPT model. The data set that I specifically trained this model on is the Microsoft Marco data set, which is the only data set that does question answering in a natural dialogue format. So that's what allows this model to function. So to show off this model, basically, it takes in a context and a question as input, and it will extract an answer in a natural dialogue fashion. So I have some like examples. This one is from the Squad data set. And then there's another one that's just from Apple customer service. And neither of the model has not been trained on neither of these. So like these are like completely new situations that it's seeing. So now if we feed it this context and we ask it, in what country is Normandy located? You can see that like the information is located inside the context, but it's like somewhere deep within this paragraph, which we are too lazy to read, and we would like the model to figure it out for us. So the model will tell us that Normandy is located in France, which you can see it is. The information is located inside this context. You can also ask it, when were the Normans in Normandy? And they'll say the 10th and 11th century, which is present inside here. You can also ask, from which countries did they come from? And this one takes a bit longer because it's just generating the text, but it says they were descended from Denmark, Iceland, and Norway. And if we ask who the leader is, they say it's Rollo, which it is located here, the leader Rollo. Then we can ask, when did their cultural identity emerge? It says the first half of the 10th century, which is located over here in the paragraph. So we can also ask it like something more tech related. Like then it extracts this part out of the context. And it says yes. Okay, yeah, so this is like the part of the neural agent assistant which will be able to answer questions from the customer. So now I'm going to show off the complete end-to-end system. So basically, to summarize, like what we have presented throughout the course of our internship is a system that is capable of taking an input query and either generating a dialogue response or answering the question if possible, as well as identifying the intent of the input. We will also be releasing our fine-tuned models of various sizes and trained on various data sets to the public, as well as our GitHub repo, which will soon become public. And this code base is able to easily fine-tune any of our existing models, either Hugging Faces or the ones that we've released, on your own custom data set, which is very useful if you have domain-specific data that you would like to use. Some challenges that happened were that, like, personally, I've never worked with NLP, so like this was like a new experience for me. And generic dialogue is an extremely open-ended question, which is why we've decided to focus on specifically things that can help customer service, like Q&A or like intent identification. So to recap, the end-to-end pipeline is done by first classifying if the query is something that requires a generic dialogue response or a question. And then if it is generic dialogue, we will use our generic dialogue model to generate the response. If it's a question, we will identify the intent of it. We will use the sentence transformer to go through our database of information and find the context that is most similar to the question semantically. And then we will input that selected context into the user query. In this demo specifically, I will be showing off sort of the binary classification part as well as the answer generation part, which have been the models that we trained ourselves. The dialogue portion is currently using Hugging Face's pre-trained dialogue GPT, and the context retrieval part is being done by a pre-trained sentence transformer. Intent identification is not going to be done in this demo, but you have seen it previously already in Elaine's demo. And like, just as a note, this pipeline is not perfect. We can further improve the pipeline by fine-tuning both the dialogue and the context retrieval parts. Dialogue GPT in particular, it was trained on Reddit data, so it's kind of prone to doing informal dialogue, and it's also prone to making Star Wars memes, which is it's really prone to doing that. And the sentence transformer is kind of like the bottleneck of the entire pipeline right now. We could ideally we could improve this by fine-tuning it on domain-specific data to improve its accuracy for getting the best response. So now I am going to show it off under the context that this is something that's going to help U of T students in getting their T cards. So what Elham has done is she has made a sort of like mini data set of information that was just scraped from the U of T's T card help site. So there's a bunch of information here on like how to get your T card, like what to do with your T card, how is your T card useful, and things like that. And this is going to act as the model's knowledge base. So now if we ask it some questions, we can ask, what is a and then the binary classification notices that it is a request. This is the context that the sentence transformer has decided is the most semantically similar and useful, and the probability of that is around 66%. And the answer the model generates is, it is your physical identification for academic and on-campus purposes. If we give something like generic, it will identify it as general, and then Dialogue GPT will give a general response. And then if we ask it some more questions, like who needs a T card? It is a request. This is the context that it gives, and the answer that it's generated is students, staff, and faculty. And then we can also ask, what are the photo dimensions I can upload? Photo dimensions are 300 by 370, and then the JPEG format with a maximum size. And how do I activate my uTor ID? Yeah, see, in this case, the context that it chose is not the best. It doesn't actually have information on how to activate the uTor ID, which is why the answer itself is just like, it's not useful. So far the context retrieval part requires like more help in the future. And do I have to pay for my T card replacement? And the answer is yes, you will have to pay the $20 replacement fee. Okay, so this is the end of our demo. If anyone has any quick questions for either us or for this model, you can like leave them in the chat or like say them out loud.